Hi friends, this is a new topic, transition and inner transition element. This topic is from inorganic chemistry. In this topic, we studied the two blocks of the periodic table. Previously, we studied topic, periodic table and their properties, in which there are four blocks. This is the outline of periodic table. This is S block, this is P block. In between S and P, the block is present that is called D block, and bottom of the periodic table, which is F block. We focus on the two blocks, that is D block element and F block element. In which D block element there are four cells which are present between third group to 12th group. This is the position of D block element in between the period. So in between the group. And in period, these elements are present between 4th to 7th period. In the 4th period, the elements are present scandium to zinc, which are also known as 3D series. Yttrium to cadmium, which are also known as 4D series. Lanthanum to mercury, 5D series, and actinium to copper-cerium, 6D series. These names derive from their last electron enter in D subshell, which is 3D. So these are known as 3D, 4D, 5D and 6D series. Now we focus on the new point, position in periodic table of D block element. The position of D block element in between groups 3rd to 12th. While period we seen previously 4th to 7th. These elements are known as transition element because these elements present between S block and P block element. These elements show both properties of S block and P block. So they are also known as transition element. And the next point is general electronic configuration. The general electronic configuration is very important point in the topic because the last electron enter in D subshell and here previously S subshell is present. So the general electronic configuration is N-1 D 1 to 10. Now general electronic configuration, which is N-1 D 1 to 10 and NS 1 to 2, which means the last shell is NS and previous shell is N-1 D. So N-1, that means it is penultimate shell. So last electron enter in D subshell, which is inner shell, and S subshell, which is completely fulfilled. So now we focus on the electronic configuration of each series. So first 3D series, the electronic configuration of 3D series ranging from AR 3D 1 to 10, 4S 1 to 2. For 4D series, KR 4D 1 to 10, 5S 1 to 2. For 5D series, XE 5D 1 to 10, 6S 1 to 2. And for last 6D series, radon, 6d 1 to 10, 7s 1 to 2. So here concentrate on the last electron entering in 3d, 4d, 5d and 6d subshell. So the name are 3d series, 4d series, 5d series, 6d series. Okay, now the next point is electronic configuration of first transition element. We see in the table elements, symbol, atomic number, expected electronic configuration and observed electronic configuration of each element. In the series there are 10 elements which are scandium, titanium, vanadium, chromium, manganese, iron, copper, G. The symbols are scandium Sc, titanium Ti, vanadium V, chromium Cr, manganese Mn, iron Fe, cobalt Co, nickel Ni, copper Cu, zinc Zn. An atomic number ranging from 21 to 30. Now, the expected electronic configuration is the important part for the series is the electronic configuration of scandium is Ar 3d1 4s2. So, now we only added one by one electron for each element. The electronic configuration made like Ar 3d2 4s2, Ar 3d3 4s2, Ar 3d4 4s2, Ar 3d5 4s2, 3d6 4s2. And last 3d10 4s2. So we see only change is in 3D. One by one electron is added starting from 1 to ending with 10. So the electronic configuration of 3D series is Ar 3D 1 to 10, 4s 1 to 2. This 3D 1 to 10, this is because from here 3D1 to 3D10 electron can be filled. So now the next is observed electronic configuration. The expected electronic configuration and observed electronic configuration are same except only two cases, for chromium and for copper. Chromium and copper, the observed electronic configuration is different from expected electronic configuration, and these are Ar 3d5 4s1 and for copper Ar 3d10 4s1. So here electronic configuration is 4s1 and here electronic configuration for other cases 2. So the general electronic configuration of 3D series is 3D 1 to 10, this is because, and 4s 1 to 2, this is because 4s2 and 4s1 cases of expected and observed electronic configuration. So the electronic configuration of observed and expected are different for chromium and copper. This is because the expected electronic configuration of chromium Ar 3d4 4s2. 3d subshell contain 5 orbital and 4s contain 1 orbital. Here, in the case, the energy level of 3d subshell and 4s are nearly same. So electron can be transferred in one another easily. So this 3d subshell have only one electron required to complete its half field. Half field because each orbital contain one electron and have capacity of 2. So 2 capacity and 1 electron contain, that means it is half field. So completely half filled shell require only 1 electron which is transferred from 4s. So now electronic configuration become 3d5 4s 1. In that case the electronic configuration is half filled, so it have extra stability and each element having extra stability. So that's why the chromium has electronic configuration is 3d5 4s1. Now for copper, the electronic configuration is 3d9 4s1. First 5 orbital contain single electron and then next get pairing. And 4s contain 2 electron. In that case, here half field have extra stability and here full field have extra stability. Each orbital having capacity of 2 electrons. Already 4 orbitals are full filled. Only 1 orbital remain which carrying 1 electron to get its full fill condition. So electron can be shifted from 4s to 3d. Then electronic configuration becomes 3d10 4s1 which have extra stability. So that's why the electronic configuration of copper is 3d10 4s1. So that's why these are the two expected and observed case difference because of half field condition stability and full field condition stability.